Welcome to Nearpod Lesson 6.6, Balancing Chemical Equations. So this is the title of your notes and the 3 things you need to be able to do by the end of this video. So far, we've been talking about chemical equations or recipes in chemistry to make things that we might need, like aspirin. We also figured out how to predict products in the end, and then now we're focusing on how to calculate how much we need to make a 500 milligram or 250 milligram pill of aspirin. So in unit or lesson 6.4, I had you try to predict products and things like that, and a lot of you are able to, but you might notice something odd about this equation, especially if I draw all of the elements and their molecules out. So for example, if you notice in the reactants, there's these 3 reactants or ingredients, and then at the end, I'm left with this, right? Do you notice anything odd about this particular equation? Well, you might notice that the second oxygen kind of disappeared, right? So before, in my reactants, I have 1 Mg and 2 oxygens bonded together. Afterwards, I still have that 1 Mg, 1 oxygen. So where did that second oxygen go? Right? So this equation as it is doesn't quite make sense. It's like if I had a recipe for a ham and cheese sandwich that required 2 slices of bread, 1 slice of ham, 1 slice of cheese, and then in my product, I said, okay, here you go. Here is a grilled cheese sandwich. You might be wondering, where did that ham go? So here's the thing. We need to do something called balancing equations. And balancing equations is essentially the process of changing coefficients so that the number of reactants is equal to the number of products. So this is one of the things you need to know in red here. And by coefficients, I mean these numbers in front. Right? So we discussed this in previous lessons as well. Right? So for example, if I want to change the coefficient so the number of reactants, the stuff before the arrow, is equal to the number of products, something that I can do is I might want to add one more O on this side. But I just can't add another letter O by itself, since that would mean MgO2. The charges wouldn't add up, and I would essentially have a completely different recipe, right? Even though it was altered a little bit. But what I can do is I can add another MgO. So in this case, I have a total of not 1, but 2 MgOs, right? But that kind of throws the Mg off on the reactant side, because in the reactant side, I only have 1 Mg. But again, I can change the coefficient. I can change this to 2 Mg. And now both sides, both my reactants and products are balanced, because in my reactants, I have 2 Mgs, 1 molecule of O2, right? So 1 times 2 contains 2 oxygens. And on the product side, I have 2 Mgs and 2 Os, the same amount of elements on my reactant side as I do on my product side. So when I do things like this, I'm working with the numbers in a chemical equation or a recipe in order to figure out their amounts and how much of things I need of each. This study is essentially called stoichiometry. Messed up on the spelling here though. Delete that part. Stoichiometry is how we pronounce it, and it's just the study of chemical equations and the amounts involved, right? So make sure you have these two definitions, and in the next video, I'm going to show you how to balance equations without using these element pictures.